just doing the limit of the same problem. So we're just going to rely on one limit statement. All right, so this is kind of like a miniature problem here within this larger problem. So let's evaluate this limit. What's the first thing we do? Yeah, if we see a real number, we're going to plug in that x value. Because we don't know what's going on, right? We don't know, is it continuous? Is there a hole? Is there asymptote? We're not going to know until we evaluate the limit. So we'll enter 2 in for all the x's. And what do we get? Yeah, we get 0 over 0. So 0 over 0 is very specific. It tells us something very important about our problem. The limit does exist, but there's a hole in the graph that's preventing us from getting a good read as to what that limit is. But we do know the limit exists. We should do a little bit more work to get to it. Limit exists, but there's a hole. So we're going to try to resolve that 0 over 0. We have two options. Either we can go through factoring and cancel out, or we can go through L'Hopital's rule. Okay. I'm going to go through L'Hopital's rule here. So L'Hopital's rule just says take the derivative of the top, separately take the derivative of the bottom, and then we'll see if we can reevaluate. So 2x squared minus 3x becomes 4x minus 3. X minus 2's derivative becomes 1. And now we're just going to reevaluate. Enter 2 in for x. We get 8 minus 3, which is 5 over 1. 5 over 1 is just 5. We have our order pair at 7. We have our limit at 5. Is the third condition going to pass? No, right? They're not the same, right? They're not the same. So we'll say f of 2 does not equal to the limit so we expect a hole in the graph like what we experienced here at B. So just a quick visual here. No need to graph it if you don't want to, but you want a quick visual. The order pair is living up here at 7, but the limit is headed towards a different y value. And because of that, we should be able to narrow down to our answer choice. Okay, so it says, which of the following statements is true? Function is continuous. Okay, that's obviously not true. All right, we know there's a hole in the graph. Function has a removable discontinuity at x equals 2. That just means that there's a hole in the graph, and we see that's definitely true. So there's our answer choice. Okay, let's just go down the other ones to confirm why they're incorrect as well. F has a jump discontinuity. Jump discontinuity means the limit does not exist, but we know that's not true, right? We're able to find the limit. There's no vertical asymptote here. And then our function has discontinuity due to a vertical asymptote. There's a hole, but there's no vertical asymptote. Right. Vertical asymptote would be where the x minus 2 does not cancel out. But if you were to factor this out, you're going to get x minus 2's to cancel out, which means that there's a hole. But if there's a variable left over in the denominator, and the numerator doesn't do anything to cancel that out, then we have a vertical asymptote. Like here, there's a hole, but no vertical asymptote. Okay, any questions with 2? Okay, take a look at 3. Now, if you look at 3, look at how 3 is also a piecewise function as 2, but we have notations that looks a little bit different. Here, notice that we're dealing with inequalities. Here, we're not dealing with inequalities. So if we see an inequality, usually that's an indication that we need to rely on one-side limits, because we have a function that's defined on one side of 2, another function on either side of 2. We need one-side limit to evaluate them separately because we have 2 separate functions to work with. And it's asking for a limit as x approaches 2, so we're going to apply, use one-side limit. So we'll do limit as x approaches 2 from the left side of 2, and we'll also do limit as x approaches 2 from the right side of 2. So from the left side of 2, we know that's referring to the natural log of x. From the right side of 2, we're dealing with that x squared natural log of 2. Okay, we have 2 separate directions. We're going to evaluate each of these one-side limits separately and see if they are in agreement. If these values are in agreement, we know that they're both headed towards the same y value, and we know the limit exists. But 2 goes in for x. Don't worry about the decimal. We're just going to do whole numbers initially. So natural log of 2. We'll enter 2 in for x here as well. I get 2 squared natural log of 2. And if you look, right, these are not the same y value, right? So what's happening is on one side of 2, we got natural log of 2 headed towards one value. Another is headed towards 4 natural log of 2. We see there's a disconnect. Therefore, the limit does not exist because we don't have a consistent movement towards the same y value. Okay, any questions so far? Okay, number 4. Number 4 is pretty straightforward. If you look at this, you know that pi is a real number. You'll evaluate the limit. You're going to see 0 over 0. You do L'Hopital's rule, you reevaluate, and then you get your answer. And it's pretty straightforward. So if you see this on multiple choice question, then you'll go through that process, no issues. However, if this was on the free response question, we got to be careful with a few things. Okay, so I want to talk about notation and how College Board is a little bit there's a little bit of a quirk with how they grade FRQs. Okay, so I want to put this on a separate page and just talk about that in order to help save potentially some issues in terms of points being lost or gained. Okay, and this, let me zoom out a bit. This is not an issue in the classroom. I think most teachers probably don't worry about this, but this is an issue on the AP exam. So we're just kind of understanding how things are being graded and to be able to work around those parameters. So the issue is this thing called linkage issue. Okay, and it has to do with the equal sign. When you're going through a problem and I ask you to show work, if you use equal sign, a lot of times equal sign just means that I'm just going from one step to the next, right? You're not using it literally, right? But on the AP exam, if you have an equal sign, and let's say you have equal sign, and you have and all you're using equal sign is to connect the steps. But if on the AP exam, if they see that this step is not equal to this step, but you have an equal sign somewhere along the way, they're going to take that equal sign very literally, and they're going to take off a point. So the suggestion is don't use equal signs on FRQs, use arrow. If you use arrow, then they're not going to take points off. It just seems like such a arbitrary thing, but and I had a chance to grade AP exams these past couple of years, and it's frustrating to be grading a perfect set of paper and take off points because they're using equal sign instead of arrows. But I think that's something that I think as a grader, we just have to understand, okay, that's the decision that they made. At least they're consistent across all the tests, but I feel like, well, if that's the case, I want to let my students know so they're not just losing needless points all over the place. And so this especially shows up on L'Hopital's rule, because L'Hopital's rule, so many times we say equals 0 over 0, and 0 over 0 is equals 0 over 0 is troublesome. That, like, it's not mathematically sound, but the way around it is if you just use arrows, then they're not going to take points off. Okay, so we're going to practice this L'Hopital's problem and just practice using arrows from one end to the next. Just don't have any equal signs at all. Okay, so let's practice that. Okay, so first thing we do, we're going to evaluate our limit just to see what's going on. And this is only an issue on FRQs. On multiple choice, they're not looking at your work. But on FRQs, we definitely just have to be careful with try to limit the use of equal. It's not, if you use equal sign, they'll take points off. It's if you use equal sign, and if both sides of the equal sign are not directly equal to each other, that's when they'll take points off. So just be careful with when you use equal sign. Or if you don't use equal sign at all, then that's even better. That way you don't have to worry about it. Okay, so replace all the x's with pi. Okay, arrow. Cosine of pi is -1 plus 0 plus 1. That's going to be 0 over 0. Again, don't use equal sign here. All right, so we know 0 over 0. Our condition is right for L'Hopital's rule. On the FRQ, you don't have to say L'Hopital's rule. You can just jump directly into applying it. So I'm going to jump directly into finding the derivative. As a reminder, cosine's derivative is negative sine. Sine's derivative, sine of u, becomes cosine of u times u prime. So cosine becomes negative sine of x. Cosine of sine of 2x becomes cosine of 2x times 2. The plus 1 will go to 0. X squared becomes 2x. Careful with that pi squared. Does that become 2 pi? Good, right? Pi squared is a constant. Don't treat that like a variable. That's just going to go to 0. Arrow. Evaluate. Pi in for x. Now that we have a different version of the problem, we're hoping that this will no longer give us 0 over 0, but give us a real number that we can represent as our limit. Arrow. Sine of pi is 0. Cosine of 2 pi is 1. So I have 0 plus 2 times 1. That's just going to be 2 over 2 pi. And that's just the same thing as 1 over pi. That's the answer choice, 1 over pi. Yeah.
Would this be non-calculator?
Yeah, this would be non-calculator, right? This would be a non-calculator question. Okay. Any questions here? All right, let's go to the next page. We're still talking about limits, but now it's limits as x approaches infinity. We got to be careful. This is a different set of rules. If we see infinity, we're going to be comparing degrees. Okay. If you look on your formula sheets, I say that if my numerator and denominator are equal, if they have the same degree, then my limit is just the ratio of the coefficients. Okay, right now it doesn't seem like the same degree, but let's do a little bit of cleanup, right? This is not really x to the fourth sitting up here because there's a square root over it. So let's resolve that square root. What is this going to clean up to be? Yeah, 3x squared, right? We don't care about that plus 1 because that's a lower degree. We only care about the highest degree. Only the highest degree is going to have an impact as we approach infinity. So we see the degrees match. If degrees match, we know that our limit is just the ratio of the coefficients. So we look at the number sitting in front. We have 3 and 1. So our limit is just going to be 3 over 1, which is 3. Number 6 is more L'Hopital's rule that you can practice on your own. Number 7 is going to be power rule. But you got to be careful with how you do power rule. You want to bring everything up to the top, resolve it, then do power rule, and then clean up. So I'll let you guys do that on your own. I have the keys for you guys to reference. What I want to talk about is number 8. I want to talk about how sometimes multiple choice on the AP exam is not really work intensive. There's not a ton of steps involved, but sometimes it is conceptually intensive. So I want to kind of show you where you're not doing a lot of work, but you're having to figure stuff out. So let's look at number 8. It says, let f and g be differentiable functions with the following properties. G of x is greater than 0 for all x. F of 0 equals 1. H of x equals f of x times g of x. But they're telling us that h prime is equal to f times g prime, then f of x is equal to. So they're telling me what h prime is, but I'm going to ignore this statement for now, and I'm just going to focus my attention here. Okay. If I covered this up, and if I asked you to find h prime, what would you do? You'll go through product rule, right? So let's just pretend like we don't see this at all. Let's just go through product rule, because we know the product rule will give us a true derivative, and then we can see why is it different than the one that they're providing us, and we can maybe make some conclusions as to where to go from there. So I'm going to just, I know I got to involve h prime, so I'm going to have something to compare with. Let's just find h prime from what we know. We know this is going to be product rule. Okay, so f prime g plus fg prime. So this is my derivative I found. This is their derivative. Notice that I do have some matching pieces, but they did not include this f prime times g of x at all. So what conclusion can we make as to why our derivative looks different from theirs? Or why do you think this has disappeared from this h prime. What must be true about this if it's going to end up disappearing?
Oh, it's even 1.
It has to equal 0, right? So that's something that we got to be able to do, right? If you didn't have this product rule in front of you, maybe it's going to be harder to make that, to make that conclusion. But we do know that this is 0. Okay, so that's a step in the right direction. But the next step is, which is 0? Is it the f prime that's 0 or the g of x that's 0? Is there any hint from the problem that tells us? Okay, yeah, is it g of x greater than 0? Okay, so that kind of helps narrow down our option, right? We know that f prime must be the culprit here, must be what's causing this to disappear, which gives us that. Okay, so we know f prime is 0. Okay, so we're making some progress here. It says, so if f prime is 0, that means f of x must be a what?
Single number.
Yeah, it has to be constant, right? Only a constant is going to produce a derivative of 0. So right now, you know that f of x must be a constant since f prime of x is equal to 0. So that means we only have two options, right? It's either 0 or 1. Right? These are the only constants that we see in the problem. But is there something that we can use to narrow down between these two options? F of 0 equals 1, right? So what's the only value where I can plug in and get a 1? Okay, there's no variables here, right? So I think it's only going to be 1 that's going to work, right? If my f of x is 1, then f of 0 is going to be 1 because there's no variable, it'll always be 1. But if my f of x is 0, there's no chance that this can be true. So f of x must be equal to 1. Right? We know it's a constant. We know that it's going to produce a 0. So this is one of those problems where you're not doing a lot of calculus work, but you are doing a lot of, trying to kind of figuring out this problem solving, trying to figure out, what's the pattern here? What conclusion can we make? That's what makes this problem more difficult. Yeah.
Just to clarify, are we making that last determination based on the f of 0 portion or the equals 1?
Right. So once I knew that f prime is equal to 0, I knew that I was down to two options. Right. It's either my f of x has to be either 0 or 1. But if I tested both of these out, only one of these statements is gonna allow this to be true. Right? There's no chance that I can put 0 in for x and get 1. Right? We know that these are not in agreement. So if f of x is equal to 1, then f of 0 is equal to 1. This is a very specific case that is true for this problem, for this function. All right, so this is the property that allows us to narrow down between our two constants. Okay, any questions of 8? Okay, let's finish up with number 9. Number 9, I think, is more familiar, but we still have to go through a couple steps here. It says let f be a differentiable function with order pair 2, 3, and slope and derivative 2, -5. And let g be the function defined by g of x equals f of g of x. Okay, so this is the function that we're working with. Which of the following is an equation of the line tangent to the graph of g at the point where x equals 2? So we're trying to create our tangent line equation. So we need order pair and we need slope. Order pair, we know our x value is 2. So we have to figure out what the y value is. We'll enter 2 in for x, clean this up, maybe get it resolved down to a number. X f of x, replace x with 2, replace x with 2 here. Two times f of 2, we know f of 2 is 3, so 2 times 3 is 6. Okay, so there's our order pair. Next up, we need to find the slope. To find the slope, we need to find the derivative. To find the derivative of g of x, we have to rely on what? Product rule. Yeah. Hopefully you can see that x and f of x are clearly being multiplied with each other. We got to go through product rule. So x's derivative is 1. Back to the original. Back to f. And then g prime. The second term's derivative is going to be times f prime. Now that we have our derivative, we can replace all the x's with 2's. And once we do that, we should be able to get these notations down to a numeric value. Once we get it down to a numeric value, we have our slope. Once we have our slope and our order pair, we'll do point slope, and then we can find our answer choice. So I'm going to enter 2 in for all the x's. I get f of 2 and f prime of 2. I go to what's given in the problem. F of 2 is 3, f prime of 2 is -5. Clean that up. I get it all the way down to -7. I have my order pair. I have my slope, point slope, answer choice D. Okay. There's a few more things for us to do on this page, in this packet, but we'll hit those tomorrow, and then I have a second worksheet where we can start exploring our second half of first semester, which is related rates, curve sketching, and derivative graphs. All right, thanks everyone. Hope you guys have a great day. Remember, your assignment is due tonight. I'll send out a reminder, assignments 1 through 5, so get that turned in so you can get full credit for them. All right, have a great day, guys.